Ever since the beginning of the pandemic, we've been hearing a lot about flattening the curve. But what does that really mean? To find that out, we will need to understand how we model cases of COVID-19. The first model which we can use to model COVID cases is with an exponential function. The exponential function can be used to model a rapid growth in COVID cases or a rapid decline in cases. This is the curve which everyone is talking about when they say we need to flatten it. There are a few things which we need to keep in mind when using this function to model cases. Firstly, the base exponential function, 2 to the power of x, has a horizontal asymptote at y equals 0, which means that if we wanted to model an eventual elimination of COVID, this function can never go to 0. Secondly, this model assumes that cases are either increasing or decreasing at the same exponential rate, which never happens in real life, meaning we would be better off using it for short periods of time or just to get a general estimate of case numbers. An exponential growth rate would signal that a lockdown is needed. The second model which we can use to model COVID cases is with a logarithmic function. A logarithmic function is what we are referring to when a flat curve is talked about. Logarithmic functions increase much slower than exponential functions. This is what you are aiming for with a lockdown before the cases begin to drop. There are a few things which have to be taken into account when designing a logarithmic growth model for COVID cases. Firstly, a restriction would have to be placed on the range so that the function does not go below 0, as there are no such thing as negative COVID cases. Secondly, there is a vertical asymptote at x equals 0, and so if you wanted to connect this logarithmic model to the existing data we have and use it as a projection for the future, vertical and horizontal translations may need to be made, as well as restrictions on the domain of the logarithmic projection so that it does not go into the old data. Lastly, this model is better for longer periods of time when compared to the exponential growth model, as it is much better at showing averages. A logarithmic growth model would be a good signal that a lockdown is working. We can analyze these models to try and understand the benefit of the lockdowns. On December 19th, experts released projections which stated that with a 7% growth rate in cases and no lockdown, and this was modeled using an exponential function, then by the 24th of January, we would have around 28,000 cases per day. The province of Ontario went into lockdown on December the 26th, 2020. The aim of the lockdown was to achieve a logarithmic growth rate and then to hopefully see a decline in cases. What ended up happening was that we went from exponential growth to exponential decline beginning around 2.5 weeks after the lockdown went into effect. Here is a comparison between December 19th projections and what actually happened. This defied even the experts' predictions, as on January the 12th, the Science Table released new projections which predicted that case numbers would continue to rise under the current restrictions at the time. Here is a graph of case numbers from the middle of November until the end of February. As you can see, the lockdown had a huge impact on cases, reducing our daily case number by around 75% between the period of early January and the end of February. To those who don't believe lockdowns work, the numbers don't lie.